How many hours have you lost just trying to get your local dev environment to behave? Spinning up APIs, configuring databases, syncing services, all of it happens before you even touch a line of business logic, and it starts to feel like setup is half your actual job. Aspire advertises something different, a single command designed to orchestrate your front-end, back-end, and dependencies so they start together. It's not pitched as another layer of complexity, but as a way to make your existing tools finally work in sync. In this podcast, I'll show you the command itself, walk through the built-in dashboard that reveals what's happening under the hood, and explain why it doesn't require replatforming your stack. Because the real problem here isn't just wasted time, it's what setup is quietly taking away from actual development. The hidden time drain nobody talks about. Here's the thing, almost nobody admits. The real-time drain in development isn't coding itself. It's the hours lost to setup and maintenance, the hidden work that so often derails momentum before you've even opened your editor. That's the trap we need to put under a spotlight. Take onboarding a new hire. They join ready to contribute, open their laptop, and instead of pushing their first change, they're stuck on outdated docs that reference Docker scripts written years ago. The commands fail on their OS, the config no longer matches the reality of the stack, and soon they're escalating to teammates just to chase environment variables. What should be a productive first day turns into a scavenger hunt that slows everyone down. Now zoom out to someone who's been with the codebase for years. They make a routine update expecting to get into feature work, but instead a single service crash spirals into hours of reconfiguring logging formats, hunting through YAML files, and rebuilding containers. By the time things are stable again, half the day is gone. Nothing new has shipped, and all that energy went into keeping the system upright. Scenarios like these aren't edge cases, they're daily reality. A significant chunk of a developer's time gets eaten by startup fragility and dependency sprawl. And while each step seems small, fix a config here, restart a container there, the cumulative effect across the team is huge. It becomes a cycle of maintenance work that looks invisible on a roadmap, yet it steadily drags delivery down. This drain is more than inefficiency, it also makes the whole process fragile. Running a dev stack often feels like assembling flat-pack furniture with instructions that no longer match the pieces. You tighten one screw, another pops loose. Even when everything holds together, it wobbles. That environment works in theory, but it's always one step away from collapsing under its own complexity. The harder truth is that these loops sneak up on everyone. Developers crave momentum, the shortcut from idea to running code. But instead of speed, we keep colliding with environment issues that sap focus. It's a structural obstacle, not a personal failing, and it doesn't matter whether you're onboarding, patching, or building something new. The friction is baked into the process. This is where the question becomes unavoidable. Why are we still accepting all this overhead as normal? If modern frameworks, languages, and infrastructure promise acceleration, why does the local developer loop still feel so heavy? What would it look like if the setup cycle wasn't yet another problem to manage, but something that simply worked in the background, with no scavenger hunt involved? Because here's the tantalizing possibility, there might be a way to collapse the entire cycle. Imagine skipping the endless scripts, ignored YAML warnings, and fragile workarounds, replacing all of it with a single command that not only runs the whole stack but also makes it observable from the start. Now imagine that whole scavenger hunt could start and finish with one command, and with built-in observability. That's what we'll unpack next. A single command that changes the game. What actually changes here is that Aspire introduces a single command designed to simplify the entire startup process. The idea is straightforward. Instead of wrangling layers of YAML, fragile compose scripts, and dependency order problems, you open your terminal and type one instruction: Aspire run. We'll walk through what that looks like in a moment so you can see how services come online together without the constant manual adjustment developers are used to. Normally, getting a local stack running means writing YAML for each service, wiring environment variables, checking health probes, and hoping containers start in the right sequence. Even with Docker Compose, those files quickly bloat into hundreds of lines for networking, volumes, and service coordination. Once it's all running, the real work begins, chasing through log windows and repeat edit restart loops every time something breaks. It's a workflow we accept as normal, but it eats both momentum and focus. Aspire's approach is to reduce that burden. When you run its startup command, the stack comes online as a coordinated whole. Your front-end service knows where the back-end lives without extra patches. The database is ready before connections are attempted. Background workers idle until messages start flowing. Whether you watch it in real time or just trust the system to arrange things correctly, the point is that orchestration no longer feels brittle. It's designed to help existing projects start cleanly rather than asking you to rebuild your stack around a new model. The part that stands out is how flexibly it handles mixed environments. Yes, .NET scenarios are fully supported, but if your stack mixes a Node, JS frontend, a Python task runner, and custom Docker containers, Aspire still treats them as part of the same workflow. Languages and services aren't segregated into separate silos. You can keep your heterogeneous setup, but boot everything together with a single command. If you're wondering whether it works with your existing Docker files, the answer is that Aspire is intended to work with what you already have. But you'll want to verify details in your own project to be sure. To keep this concrete, picture launching the terminal and running Aspire run. The services boot in a sequence that makes sense. The front end immediately routes traffic to the back-end API. The API starts handling requests against a live SQL container. Message queues come online and background processors begin consuming them. There's no new format to learn, no forks of your code base, and no special wiring files replacing your existing setup. It's still your environment, but the starting friction is stripped away. Of course, any developer will ask whether there's a catch. Tools that promise to eliminate boilerplate often end by locking you into a custom configuration language or enforcing a rigid project structure. Here, that doesn't appear to be the case. You keep your Docker files and existing services. Aspire's aim is to orchestrate them, not replace them. That said, check current documentation to confirm the boundaries, especially if your project includes custom networking or non-standard container builds. This design shift carries a bigger effect than just time savings. When startup becomes dependable, you stop thinking about YAML tweaks or container restarts before coding. The effort you save isn't only minutes at boot, it's attention that would otherwise be drained into system upkeep. The environment is ready, so you return to your actual work instead of firefighting infrastructure every morning. And here's the real turning point. Aspire doesn't just launch services, it changes what the startup process delivers. Because once your stack is running, the next issue isn't bringing it up. It's figuring out what's happening inside it. That's where hidden complexity shows itself most, when you're debugging without guesswork. Debugging is where developers feel the grind most sharply because diagnosing problems across a distributed stack rarely happens in one place. A background worker fails, the API logs look fine, and the database appears healthy until you realize they're out of sync. That pattern of jumping between terminals, log folders, and separate dashboards isn't unusual. It's the everyday loop that turns a small issue into a morning lost. The core challenge isn't just bugs themselves, but the fragmented context around them. In a simple monolith, the error is often in one log. With multiple services running side by side, even minor issues can sprawl. An API may show as running, but in reality, it can't reach the database. Another service might look stuck when it's actually waiting on a queue that never started. Without one view that ties all this together, you're chasing fragments and relying on educated guesswork more than actual debugging. Here's where Aspire aims to change the process. Alongside the startup command, it provides a built-in way to surface key signals in one place. According to the docs, that includes logs, service health states, and traces captured through OpenTelemetry. If those integrations work as described, it means you no longer have to piece the picture together manually. Instead of checking 3 different tools, you open the Aspire dashboard, check which services are healthy, and if there's a failing service, follow its trace to see why. Please verify with the product documentation how these features behave in current builds, especially the handling of OpenTelemetry. Presented as a flow, it works like this. First, you launch your stack with Aspire Run. Second, you open the Aspire dashboard. Third, you scan the health indicators. If the API can't talk to the database, you'll spot it immediately. And finally, you follow the linked trace to confirm where the failure originated. Rather than deciding which terminal window to check first, you already have the bigger picture available. Confirm these steps are accurate for the product before recording, but this is the intended workflow the docs suggest. To make this practical, consider a scenario that many teams run into. The API container boots and reports healthy, but every request it handles fails. The real issue isn't the API, it's that the database connection is broken. Normally, you'd bounce between API logs, database CLI tools, and maybe a monitoring tab somewhere else. With Aspire's dashboard, both the API's health state and the trace showing failed DB connection attempts appear in the same view. That immediately answers the question of where to start without the detours. This unified context matters because it strips away the invisible cost of debugging. Most of us have spent as much time choosing the next tool to open as we have fixing the root cause. When the choice is gone, because logs, health checks, and traces share one window, we recover that lost focus. Debugging doesn't necessarily become effortless, but it becomes linear. You know where to look, in what order, and why. One detail worth noting is how Aspire handles observability frameworks. For teams that haven't wired tracing across every service, Aspire's design can auto-enable OpenTelemetry out of the box. For teams that already use it, the data feeds directly into the same dashboard. This means distributed tracing isn't a separate initiative or another backlog item. It's part of the runtime environment. Again, verify these claims against current documentation. If Aspire only exposes partial tracing data, adjust how this is presented on screen. The payoff is less about fancy visualization and more about clarity. Unified context means faster fixes and fewer blind guesses. You're working from the whole picture instead of dozens of scraps. which keeps debugging closer to diagnosis and further from scavenger hunt. Less time in setup, less time in debugging overhead, more time aimed at actual solutions. And while that shift is meaningful on its own, it raises an even bigger question. If debugging is easier when everything is collected in one place, what happens when the same principle is applied to microservices themselves? Most tools still put conditions on how you run them. They expect a rewrite or a migration before you see the benefits. That's often where teams hesitate, and it's where Aspire takes a very different path. Microservices without the rewrite. Most tools that promise to simplify microservices start with a catch. They look appealing, but only if you agree to reshape the way your system is built. That often means discarding parts of your environment, rewriting services so they fit into a new framework, and restructuring years of work. On paper, this sounds like modernization. In practice, it's expensive, risky, and often impossible to justify for teams already running production workloads. The safer option becomes doing nothing and accepting the drag of brittle local environments. So the reality is that development teams don't operate in pristine greenfield conditions. They already maintain APIs that keep customers connected, databases carrying real business data, and background services that employees depend on daily. Asking teams to pause feature delivery to replatform that stack is rarely an option. Tools succeed when they plug into existing workflows, not when they demand a reset. This is where Aspire positions itself differently. Instead of enforcing a rewrite or lock-in around one ecosystem, it's designed to work with what you already have in place. Please confirm this against the official documentation, but the intent is clear. Minimize migration work rather than mandate it. If your project includes legacy components that still matter alongside modern services, Aspire is meant to start them together as part of the same environment. That means the conversation shifts from what must we discard to how do we run everything more reliably. Think about a typical environment. You might have an older .NET application still handling a critical workflow. On top of that, a modern frontend, perhaps in React, drives customer-facing features. Add in a containerized worker service built years later in Python, and suddenly you're juggling 3 different eras of engineering all under one umbrella. Normally, bringing these pieces together requires scripts, manual sequencing, and constant patching. With Aspire, those components are treated as part of the same orchestration target. The result isn't new code, it's familiar services that now start in sync. That inclusivity is where the tool becomes useful. Enterprises rarely operate on a single stack. They combine multiple languages, frameworks, and container strategies. By focusing on orchestration rather than replacement, Aspire aims to bring these varied components into alignment. Verify the specifics against documentation, but the positioning is that age or tech choice doesn't disqualify a service from being included. The house analogy holds. You don't rebuild every room to modernize the circuit breaker. The layout stays, the furniture stays, but suddenly everything works from the same wiring. With Aspire, legacy APIs and new microservices don't demand a costly rebuild. They stay as they are, but they share a consistent startup and operational flow. From the engineering perspective, this replaces brittle rituals with predictable environments. From the business perspective, it sidesteps the kind of migration project that halts progress for months. What this means over time is practical, not abstract. Developers stop losing cycles reconfiguring YAML or patching scripts just to launch their stack. New contributors onboard faster because the environment they run looks consistent with everyone else's. Ongoing work becomes less about maintenance overhead and more about releasing useful features. The cumulative gain isn't measured in dramatic shifts. It's in reducing the drag that teams have internalized as normal. To make this point more concrete, picture onboarding a teammate. Instead of handing them a fragmented set of config files or an outdated setup guide, they run one command and services boot in a sequence that works. They don't need to understand every legacy pattern on day one. They don't need to chase dependencies across 3 different runtimes before they commit their first change. They start coding. That's the real measure of whether a tool earns adoption. It makes both old and new systems feel like part of the same environment. One note here, confirm whether Aspire requires additional configuration files or modifies existing Docker files to work. If it truly just orchestrates, that's a strength worth stating directly. If some new declarations are needed, that's a detail your team should be aware of when evaluating adoption. Either way, the value lies in reducing the amount of rewriting, not increasing it. Ultimately, the promise isn't that Aspire erases complexity, it's that it removes the repeated overhead of bending your stack into shape. You keep the mix of old and new, and you gain a cleaner way to run it. Once that burden begins to drop, a new possibility opens, redirecting time and energy toward the work that actually brings value. And that shift brings us to the next question. What happens when teams spend less effort configuring and more effort building? The real payoff, building, not configuring. At its core, development has always been about building things that didn't exist before, features, workflows, and experiences that create value. Yet much of a developer's daily energy gets channeled into tasks that don't advance that goal. Writing Docker files, wiring YAML, massaging order of operations, none of that is why people join engineering teams. Businesses fund engineering to deliver outcomes, but hours leak away into plumbing work that produces no visible progress. That's the gap tools like Aspire are trying to close. This gap is especially pronounced in modern development cycles. Companies invest heavily in cloud capacity monitoring, subscriptions, and senior talent, but the real drag still lurks close to the keyboard. You can provision infinite scale in the cloud, but if starting your local stack feels like warming up an old diesel engine, the whole workflow suffers. The bottleneck isn't infrastructure, it's the time it takes to get rolling locally. That delay breaks momentum in ways no amount of cloud elasticity can fix. Aspire's contribution is to pull that overhead out of the loop. The act of booting services stops feeling like a half-day ceremony and starts feeling like a single step. Instead of scripts compiling, logs streaming, and containers failing one by one, services come online together. For developers, that collapse of setup overhead fundamentally changes the pace. What used to feel like walking through a checklist now feels like snapping into focus. The rhythm of iteration tightens naturally. Make a change, run the stack, test, and move forward. Onboarding shows the benefit most clearly. In many teams, a new hire begins by slogging through docs that don't match reality, patching environment variables, and confirming whether their OS aligns with half a dozen manual instructions. That's not coding, it's unpaid archaeology. Replace that with an environment that boots on a single command, and the difference is obvious. The new hire's first contribution becomes a feature branch instead of yet another note about outdated setup steps. That kind of first-week momentum pays off for everyone, not just the person onboarding. Iteration cycles also shift. It's not only about speed to start the stack, but the kind of feedback you get once it's running. Aspire's integrated observability means logs, service health, and traces appear in one coherent view. You no longer wonder which terminal to check first when an API call fails. Instead, the feedback is connected as part of each run. That compression of context shortens the debug loop, meaning developers can adjust behaviors mid-cycle instead of stopping to assemble clues. Even small adjustments like shaving repeated context switches change the feel of day-to-day work. This matters because coding is inherently creative work. Developers thrive when they can focus on problems worth solving. Configuration, in contrast, is maintenance. It doesn't build new value, it just supports the stage where value might eventually appear. The ratio between those modes is what defines team energy. Teams stuck in configuration-heavy loops feel drained, while those operating in flow feel productive. By redistributing the balance back toward building, Aspire restores some of that creative momentum. And even if the time saved on setup feels small in the moment, what compounds is the consistency. When every developer saves fractions of an hour on repetitive loops across a sprint, the effect cascades. For example, a small daily saving translates into more uninterrupted work sessions, more opportunities to push features forward, and fewer moments lost to logistic delays. Over the life of a project, that compounding matters far more than one dramatic win. It's the steady pattern of reclaimed focus that shifts delivery. The morale component can't be overlooked either. Developers enjoy closing tickets, landing features, or solving problems. They don't enjoy scrolling through config files or searching log folders just to get unstuck. When the balance tilts away from overhead, day-to-day work feels more rewarding. Individuals feel their time is respected, and teams build an environment where creating impact is the norm rather than the exception. That shift influences retention, satisfaction, and the culture of engineering as much as it influences output. Put simply, remove setup overhead, and teams spend more of their day shipping value. When progress consistently beats friction, the engineering loop feels lighter and momentum becomes easier to sustain. And this naturally raises the final point. Local development doesn't have to be the part of the job that slows everything else down. Aspire aims to strip away the slowest, least rewarding part of development and replace it with a single command approach to starting multi-service stacks. Instead of juggling containers, configs, and startup order, you get more time back for building features that matter. If setup no longer drained your focus, what would your team actually ship faster? To try it yourself, check the official Aspire docs linked in the description and run the quick start. Then drop a comment. What was your worst local dev setup story, or the single command you wish existed? If setup stops stealing your time, you get to build more. Try it and see.